B part 4, lecture 27, Noether theorem, conservation of angular momentum. From the last lecture, 26, we showed that L is equal to L prime, okay? And the rotation of the angle, see, this is active rotation, okay, not passive rotation. So x prime and y prime are related to x, y through this matrix. Now, in this case, you see, we have to consider that teeny time dependent rotation, delta theta, okay? That's a very small, you see? So, in this case, we use the Taylor series, and this leads to sine of this teeny angle here, okay? This is delta right here, delta theta, okay? So this is approximated to delta theta of t, and cosine of delta theta of t is approximate to 1. So a teeny rotation, okay, by this angle here, you see, this approximated, just substitute this here, that there, cosine 1, sine minus delta theta here, this is plus delta theta, and this is 1. You just set there, substitute right here. So this is a rotated coordinate, x and y is the origin coordinate. So let's take the derivative with respect to time on this. You see, now it's important here to understand that x prime, y prime, this is I apply the product rule, okay, because y is a function of t and delta theta is a function of t. So when you derive with respect to t, you have two terms over here. You see, likewise the y prime, okay, the y dot prime, y dot again, okay, you have the product rule applied to here. You see, the product rule applied to there. So you can write, in this case, x prime, y prime are teeny time dependent. See, that's important here. So this is a rotation, okay, this is the origin, okay, and this is a final rotation. Attention now, we are using active rotation, you see, as we said in previous videos. Now I move to the action, okay? The action here I call S. This is a function of x prime, y prime. This is look like a Taylor expansion, Taylor series expansion. You see, this x S at x of t, y of t plus a small increment of delta S plus order of delta theta square. So it's better to write here, okay, let's put, okay, I put delta theta square, so delta S square, you see, that's better. You see, that's, so let's expand this action here, you see, this over here is a t prime, you see, this over here, let's put it here, all of this I'll put here is t prime, you see, t prime of x prime and y prime, you see. Let's put a color here just to this here is t prime. And this over here, all of this, you see? See, the sum of this are the t prime. You see, this is a t prime minus, you see, minus now comes to the potential, okay? The potential just substitute here and there by x prime and this by y prime. You see, this is no dot, okay? This is just v, okay, the potential, okay? Now I will show here that this v prime is equal v. It's clear because here you develop this square here, okay? You'll be cancelled, okay? Then this will come just here. You see, I expand this over here with this over here. That's easy. There's a square of the difference, square of the sum. So this leads to x squared minus, you see, this cancel, and this here. This is, attention, this is order of 0. Okay, let's put the r delta theta square. So this comes to this over here, this and this. Quite easy, no confusion. So this here, then x squared plus y squared, you see, this is equal to x prime squared plus y prime squared, which this leads to on this. You see later over there that this will cancel, okay, when you subtract that, when you use the action. Okay, now let's expand this over here, okay? I put the square right here, base 50. See? So that's easy also, okay? You just expand this. This is the long, okay, terms. This is a algebra, okay, from high school algebra, okay? This is this leads to x dot square. You just read here and copy, okay? That's quite easy, okay? Just to get this long expression. Now this over here cancel with that, okay? And this one is square is the order of delta x squared. So I can neglect this over here. So the result of this is just this sum here, see? X dot square plus y dot square plus 2 delta dot y dot x minus x dot y. See? Now, attention now, okay? Now we'll substitute this on the action, term of x prime and y prime. You see, just all this expansion, okay, over here, okay, you just substitute this result right here in the integrand, okay? Now you separate x dot square plus y dot square. You put over here, okay? And also what's left is 1/2 of m 2, you see, this is 2 over here, this you cancel. That's delta dot that multiplies just this term over here, okay? That's a green one, This is a green one, you see? Let's put over there just to make clear, see? This over here. It's this one, you just set over there. See? Now, plus order of delta theta square. So, s x prime y prime, so don't forget, okay, the initial, okay, this is this relation over here. You see? This, I expand this. This is equal to x, this s of xt and yt. You compare, just compare, okay, as we did before for the translation, or spatial translation. You see, you just compare this, okay? Then you write, okay, the delta S, the blue one, okay? This is X of X and Y. You see exactly what is written over here. You see, this is the blue one. I'll put there the color, okay? I put here, this is delta S. See, this delta S over here, okay, delta S over here is just this term over here. That's why I write delta S, I just copy from there to here. You see, delta S is this integrand here, dt. Now, integrating by parts, okay, and I set delta S is equal 0, it just, I come to this term over here, you see. So this is this will be 0, you see, because delta theta is quite small, you see. That's I imply, okay, this must be, okay, equal to 0, the extreme, as we did from the Euler equations, you see, and also for the spatial translation. You see, I set at the end, this is equal to 0. So delta S is just this term over here. I integrate by parts, okay? This is 0, attention now, this is 0 at T2 and T1. That's important here, you see, by assumption. The extreme, this delta theta, I set to 0. So then the result of the integration by part is just this